look at example 4. So example saying using the limit rule. So from the previous session, we are learning about the limit of laws. Now let's use those limits to what to solve questions now. So the question is find the following limits. So the question is this question is limit of x cubic plus 4x squared minus 3 as x approaches what 3. So this is a 3, sorry. Yeah, let's not clear that, but this is a 3. Okay, so let's go direct the solutions first of all. So solutions. So for number 1 here, so we have limit of x cubic plus 4x squared minus 3 as x what approaches what. Yeah, this is 3. So for this one, how do we solve it? So this one is equal to, so let's solve them what independently. So this will be equal to limit of x cubic as x approaches what 3 plus. So this is what this, let's identify this two. So this two is just the power like x cube. So this is just the power x to the power 3, then plus. This one is the what the constant multiple. You have a constant and a function here, so it will be 4 multiplied by limit of x squared as x approaches what 3 minus limit of 3 as x approaches what 3. Yeah, so is equal to, so here limit of x cubic as x approaches 3, so this will be 3 to the power 3 plus, so this will be 4 plus limit of x squared as x approaches 3, so this will be 3 squared minus, so limit of a constant is what a constant, so here it's a 3, so 3 cubic is what 27 plus 3 squared gives us what a 9, so 9 multiplied by what by 4, this gives you as what 36 minus 3. So 27 plus 36 minus 3. So 36 minus 3, this gives us what 33. So you have 27 plus 33. So this 3 plus 7, this gives you a 0. This 3 plus 2 gives us a 5 plus and 1 gives us a 6. So this one gives us 60. So let's look at our example 2. So our example 2 is saying limit of x to the power 4 plus x squared minus 1 over x plus 5 as x approaches negative what 2. So this 2 is what a combination of the quotient through product, oh sorry, quotient through sum rule and the difference rule. Yeah, so let's break it down the same way we did this one. So this one will be limit of x to the power 4 as x approaches what negative 2 plus limit of x squared as x approaches negative 2, then minus limit of 1 as x approaches negative 2 over limit of x as x approaches negative 2 plus limit of 5 as x approaches negative 2. So for this one, so limit of x to the power 4 as x approaches negative 2. So where there is x, you put negative 2, so to be negative 2 to the power 4 plus here where there is x squared, you put to be negative 2 squared minus. So this one is limit of 1. So 1 is a what? A constant. So this will maintain the same 1 over limit of x as x approaches negative 2. This one where there is x, you put negative 2 plus. So limit of 5 as x approaches negative 2. So this 5 is what? A constant. So we maintain the same 5. So here on below here you can have negative 5 plus negative 2 plus 5 gives you what? Positive 3 below here. So negative 2 to the power 4. This gives us what? 16. Positive 16 plus negative 2 squared gives us what? 4 minus 1. So 4 minus 1 gives us what? 3. So 3 plus 16 gives us what? 19. So this will be 19 over 3 as our final answer. So now let's look into our third and final example. So example 3 is limit of root of 4x squared minus 3 as x approaches positive 2. So yes, so for this one, we're going to do the same thing we did. So this will be limit of 4x squared as x approaches 2 minus limit of 3 as x approaches 2. Then introduce the roots. So what is x what? You put a 2. So this one to be 4 multiplied by limit of x squared. So it should be 2 squared minus. This is a constant. So the limit of a constant, we said it's what? A constant itself. So this will be a 3. Then introduce a root here. So it's equal to 2 squared gives you a 4. So it will be 4 multiplied by 4, which is what? 16 minus 3. A root there, which will be equal to. So 16 minus 3 is what? 13. So root of 13. Now, 13 doesn't have an exact value in numbers of a root. So the root of 13 doesn't have an exact value. So you just end here. So this is the limit of root of 4x squared minus 3 as x approaches 2, which is equal to root of 13. So this is our final answer. So this is where we end on the laws of limits.